AWS friends, in this video we're gonna have a look on how EC2 is already working with IPv6 on AWS. In the last video we have set up already a VPC for IPv6 in Dualstack mode, and as you can see, this is what you already should have in your AWS account to get started and follow the examples here. So this is a VPC with a CIDR range for IPv6. You can set up this as described in the last video on the VPC dashboard, or please also have a look in my GitHub repo for the IPv6 examples. For example, you will find here not only CDK and Terraform, but also CloudFormation. And if you want to set up a VPC, a Dualstack VPC with infrastructure as code, you can run, for example, this YAML file in your CloudFormation console and deploy it, and you will have a VPC ready. You find here more examples, like for example also the EC2 instances we're going to launch by now for a web server or a Bastion host, and as you can see, elastic load balancers and Fargate services. We will now going to launch our first EC2 instance. We will try to set up a web server in our public subnet. So as you can see, we have in our VPC which is already ready for our examples, 2 public and 2 private subnets. So our first instance is a web server in the public subnets. So let's call it web server. We go with the Amazon Linux image, and important thing, you should select a T3 instance, not T2, to get the full support for IPv6. I will select a key pair. If you don't have yet one, please create a key pair for your instance, so we will also test how to SSH into the instance. Important, this is the default VPC. We will switch to our IPv6 VPC, and as mentioned, it should be in one of the public subnets. We will allow a public IP4 address also, and important, we have to enable the IPv6 IP address. Yes, we can create a security group, and yes, we will allow SSH. We will also allow to ping the instance, and not only for IPv4 but also IPv6. And of course, since it's a web server, we should allow HTTP or HTTPS. For our simple example, HTTP is fine, and that's the settings we will need to communicate SSH, ping and HTTP. This is fine for now. On the advanced details, I will add my instance role. If you don't have an instance role, please create one, or you can also find the example here in my CloudFormation templates. It's important to add the instance role to allow Sessionsmanager to connect to the instance. We will enable these DNS settings, especially the IPv6 one here. The rest is quite fine, and since it should be a web server, I will add here the user data script, and by now I can launch the instance. Our instance is running quite nice, so we have a web server, and as you can see, there is a public IPv4 address. That's not so interesting for us right now, a private IP address, but the more interesting thing, the IPv6 address. We're gonna copy this, and as mentioned, we should allow traffic to SSH into the instance for IPv4, and the important thing, the IPv6. We should allow HTTP for IPv4, IPv6, and also we should allow a ping to our instance. And by now we can see if we can, for example, ping the instance, then it's in the public subnet. This should work quite fine. And we can also see if we can SSH into our instance. So this is the command, and you just need actually here to include here the IPv6 address instead IPv4. And yes, we can here SSH also into our instance, and as you can see, this is working quite fine. So what else? We can also, since it's a web server, open our web server by its IPv6 address. We need this syntax, oh not this one, we need the syntax in brackets of the IPv6 address, and yes, you can see it works. So this is so far quite nice. What else? Since we have connected a sessions manager role for our instance when we launched it, we should be able to connect, as you can see, with sessions manager. And as you can see, we can also connect with sessions manager to the instance. But there's something to say about the sessions manager. It's not yet ready really for IPv6. The connection happens with IPv4. Since our instance is in a Dualstack VPC, and we also got IPv4 addresses, actually the sessions manager uses its IPv4 address to connect. It's not yet prepared for IPv6 only VPC. Keep this in mind. Also, we are able to connect by now, since we are in the public subnet. If we move later on to the private subnet, we will get problems to connect with our instance if we don't set up any VPC endpoints or some way to connect to our instance for the sessions manager. So for now, with our public IPv4 address and our public subnets where connection is possible from the internet to our web server, this is working fine. But there are restrictions in the private subnets. What else can we test? For example, we can create, let's make a record set of type AAA to our IPv6 address. So we can see if also the route 50C record sets are working, and therefore we will just do HTTP, and you can see this also works. So we are able to connect with a DNS name here and with a proper URL to our instance. Now let's try to launch an instance in the private subnet and see how we can connect to an instance in the private subnet. We will do basically the same thing. Again, we need a T3 instance. I will add my key pair, and this time we select a private subnet from our IPv6. We will not assign a public IP, but we will assign, of course, IPv6 address. We will create a security group again. Let's say security group private. And we will keep the settings for SSH. We will allow HTTP from anywhere, and we will also allow custom. We will use the same settings, add a instance role for Sessions Manager, so we can, in theory at least, connect, but we will see there the issue. And again, we can install a Apache and launch our web server in the private subnet is already running, it's ready. So let's see. By theory, we should be able to connect or ping our instance because all IPv6 addresses are public routable, but actually our subnets are set up the way we will not be able to connect to our instance because it's in the private subnets, and the route tables does not allow traffic from the internet to our private subnets. So neither the ping will work, or I will also not be able to SSH from my local machine to the instance. This cannot work. So how can we connect by now to the instance? Let's see. With Sessions Manager we have added an instance role, but as you can see we are not able to connect to the instance. This is because, as mentioned, the Sessions Manager is still working with IPv4, and the route tables again will not allow traffic to the instance. We would have to set up a VPC endpoints to allow connecting to our instance here. So connecting to an instance in the private subnet is not quite so easy. What can we do actually? Well, there's one thing. We can connect to our public instance, and from here, for example, see if we can ping or SSH into the instance. So we are connected to our public web server, and let's see if we can ping our private instance. Yes, so we can get a connection to our private instance. The network is working, and now let's see if we can use the same IPv6 address to SSH. You need to upload your PEM file, your private key, to the public instance. You can use the SCP command for this. Once you got your key path there, you can see we can also by now connect to our private instance and see if everything is working there. So that's fine. I'm back on my public instance, and what about we do a curl for the IPv6 address of the private web server, and yeah, we can see the web server is running. So it's just a question of the VPC settings to connect to it. Of course, since it's in a private subnet, we cannot reach it from our browser or from our local machine, but from our public web server inside the same VPC, you can see we can SSH into the instance, we can ping the instance, we can also open the port 80 HTML site. So this is also working quite fine. So what else can we have a look on? What about a load balancer before our private web server? So we would actually be able to allow traffic to it. So we can see how load balancer are working with IPv6. So we set up a load balancer. It's internet facing, of course. Address type should be Dualstack. As you can see, there is no IPv6 only mode available. We need, of course, our IPv6. We will add both availability zones. I have already created a load balancer security group allowing traffic on port 80 for IPv4 and IPv6. And let's see here, we can create here a target group and add, for example, a IP address. So this is my web server. Protocol is 80. I will use IPv6, and we will use these settings, IPv6, and by now we can add our instance. So let's first try our public instance here, and we include this. So by now we have created a target group. We should be able to add this target group by now to the load balancer. We don't need other settings, and we will create the load balancer. So it's provisioning. This takes a couple of seconds. We should see a target group. We should see our instance. It's our public web server, and this is gonna take some seconds. I'll be back in a minute. Our load balancer is ready by now. It's active. We can have a look on our target group. Target group we just created, web server, and we can see here in targets is our public web server. It's healthy, and we should be able, with the load balancer DNS name, by now connect to our web server. So that was a public web server, quite fine. Now maybe we can see if we can also connect to the private one. So let's deregister the public web server, and let's add our private web server. So this is this IP address, and we will register a new target. This is the private web server, and we will include it as pending. And by now we can see this is the old one, which is going to be removed, and this is our private web server. And if everything is working fine, we should here see the same page. Yes, it's healthy, so we can also connect by now to the private web server with Elastic load balancer. We would also be able to add here an alias record to our load balancer. So this way, with a load balancer, for example, we can connect to our web server with HTTP or HTTPS if set up, and this works quite fine. Perfect. We have set up a EC2 instance in the public and also EC2 instance in the private subnet. We have seen how can we connect to these instances. We can connect to the private instance, unfortunately not with the Sessionsmanager, at least not with the VPC settings we have set up, with no access to the private subnets. But we can SSH over EC2 instance in the public subnets as kind of a bastion host. We can route traffic with Route 53 and also with load balancers. This is working quite fine. Please have a look in my GitHub repo. You will find here CloudFormation's example. There are also examples for Terraform and for CDK, but these are in this moment the most advanced ones. So you can set up a VPC, you can set up the web server. You will find here also Elastic Load Balance and the record set, also a Fargate service. I got some blogs also on these subjects about VPC IPv6, so that's basically about the VPC itself, how to set up. That's the EC2 instances from this video. And there's also one more blog on how to run Fargate in VPC IPv6 in private subnets. That's quite a little bit complicated. And yeah, maybe at the end we can have a look at the commands you might gonna need. So IPv6 address is actually kind of this with 8 hexadigital numbers. That's important to know. And the commands we have seen, you can open IPv6 address also in the browser, and you will be able to open, for example, the web server sites with this syntax. So you have to use these brackets for IPv6. You can ping for Linux, for example, it's just ping 6, or for Windows ping -6, and then use the IPv6 address. You can SSH into the instance. It's basically the same command as you already know, but just adding the IPv6 address. And you can also curl with -6 into the instance. So thanks for listening, and see you on the next video.